Section 4.2 is about the area. We're starting to get into integrals. It's talking about how we use integrals to find areas of basically curved objects here. All right, and I'm going to show you an example of how we got that. And we're going to start setting a base for how we use integrals to find the area underneath curved objects. All right, so where this comes from is our first example here. We're going to use 5 rectangles to find an approximation of the area of the region lying between the graph of f of x equal to negative x squared plus 5 and the y and the x-axis between x equal to 0 and x equal to 2. So first of all, let me draw this function for us. All right, we'll say this is 5, so it's going to be up 5. It's a negative parabola, so it's an opposite parabola. It goes down like this. This would be 2. Okay, we want to break this into five rectangles. We're going to use 5 rectangles to estimate the area underneath this curve. So I need to break this up into 5. So here's one section. There's 2 sections. There's 3 sections. So 1, 2, 3, 4, 5. That little guy over there. All right. I need to break this into 5 rectangles to help approximate the area. And in the first part, we're going to start with right endpoints. So my right endpoints are going to be on the curve. And then we have this small little guy in here. If we broke the distance between 2 and 0 into 5 segments, how far does each segment have to be? Well, if we find the distance between that, it's going to be 2, and we divide by how many segments we need to have in it. All right, so we're breaking it into 5 segments. So 2 over 5. So each of these are worth 2/5. So this is 2/5, 4/5, 6/5, 8/5. And this last one over here is 10/5. Okay? So I have 1, 2, 3, 4, 5 little triangles here, or rectangles here, to help us approximate. All right. So how do we approximate? How do we find the area of rectangles? Well, when we find the area of a rectangle, we're going to take its length here times its height here. So in order to find its length, well, we know what that is. They're all broken into 2/5, right? Well, then we take it times its height. How can we figure out how high this thing goes? Well, I suppose we can plug in 2/5 into our equation, and that'll give us a point on that curve, and that's where that endpoint is. So our height, we're going to find it by plugging in 2/5 for each of these that we have. It ends up, we're going to call it 2/5 I. So when I equals 1, we have 2/5. When I equals 2, we have 4/5. When I equals 3, we have 6/5. 6/5. Hopefully you see where it's going. We've been using I's when we're talking about summations. All right? So that's what we're going to do. Actually, yeah, we're going to have a summation starting with I equal to 1, and we're going to go 5 rectangles. All right? So when I choose 1, I'm talking about my point 2, 5. All right? So here's my summation for the right endpoints. Does that make sense? Hopefully that makes sense how I got 2/5 I to be what I plug in, because when I want to go my other point here, I'm going to plug 2 in for I, and 2 times 2/5 is 4/5, and when we plug that into the function, it's going to give us our y value. So right here is our length, and right here is our height of our triangle. Okay, so let's simplify this a little farther. Let's go back and let's plug this part here into f of x. All right, so let's go. Our f of x is negative x squared plus 5. So we can have the summation as I starts at 1 with 5 rectangles, 2/5 times, all right, we're going to plug 2/5 I in for x, a negative 2/5 I squared plus 5, and then it's all times 2/5. All right. Well, we can figure out that summation then, all right? So we just pick 1 for I, plug it in there. We'll get 2/5, square it, add it to 5, take it times 2/5, write it down, and then we'll add it to when we plug 2 in there, and when we plug 3, and when we plug 4, and we plug 5. Well, I've done a little pre-work for us. We all know how to add all these up, and when we add all these up, we'll get 6.48. Okay? what you'll notice is, if you notice by all my little circles here, you notice there's always a little space in between my curve and my rectangle. So technically, the area underneath this curve is going to be slightly more than what we just found here. All right. Well, maybe that, maybe people, what if we try our left endpoints? All right. So what if we try our left endpoints? So again, we still have the same function. We still have the same function of negative x squared plus 5. All right. We're still breaking it into 5 rectangles. I'm going to draw another picture here. Okay. And draw another graph. Okay. And we're still going to break it up into 5 segments. So 1, 2, 3, 4. This will give me 5 segments. There's 1, 2, 3, 4, 5, right? Okay. Well, now we want the left endpoints on a graph. We want the left endpoints on the graph. So here's my left endpoint here. All right. So it's going to come over here like this. All right. And again, my left endpoint here is on the graph. My left endpoint is on the graph. My left endpoint is on the graph, and again here. All right, so I've broken it into 5 triangles. If you haven't thought about it already, notice when we find our summation, it's going to be slightly larger than the actual area underneath the curve, isn't it? Okay, so we're going to write our summation. Well, we got to think a little bit how our I needs to be written. All right, when we broke it down, we found the distance from 0 to 2. All right, so from 0 to 2, well, the distance is 2, and we divided it by how many rectangles we made it, so 5. All right, so our so each of these are broken into 2/5 still. All right, but if, well, this would be 4/5, and this would be 6/5, and this would be 8/5. Okay, but we got to write our I differently because we're not starting at 2/5 this time. Last time when we found the summation, we started right there because that was going to tell us our height. Well, actually, in this case, what's going to tell us our height is to the left. So our first one has to be 0. All right. So when I plug, when I use I, we're going to have to use I minus 1 because we want to go back 1 step to the left because we're using the left endpoints. Last time we used the right endpoint, so this time we have to use the left endpoints. So when I pick I minus 1, all right, for our interval, for our I's, all right, we're going to have to, so if I pick 1, it's going to be 1 minus 1 is 0. So I'm going to plug in the point 0 to figure out what my height is. So when we're dealing with the left endpoints, we have to go I minus 1 for our intervals. All right, so we're still going to have a distance of 2/5. So we're still going to have our f of x here, and we're going to take it times our width, which is 2/5. So our interval is 2/5. All right, and then we have I minus 1. So would you agree if I were to pick 1 in for I, all right, 1 minus 1 is 0. 0 times 2/5 is 0, so we'd figure out our point here. If I were to pick 2, 2 minus 1 is 1 times 2/5, so this is the x value that we're using here to find our height. That's right, because we're using the left endpoints. If I were to pick 3, all right, I've had 3 minus, whoa, okay, I'm going to lose my drawing here. I hate it when that happens. All right. I don't know why it randomly does that sometimes. Sorry about that. Okay, so we had our curve. Anyway, regardless, we found out that we use I minus 1 for our left endpoints here. Okay, we use I minus 1 because we're going back 1 step. Okay, so we still have 2/5 times I minus 1. And we got to find our height. We're going to use that. We're going to plug that into our equation to find our height. All right, and our width is always 2/5. All right, let me clarify this a little better. All right, we don't have to plug this last 2/5 into the function. All right, so let's write our summation. We have our summation. We're starting I equal to 1. We're going to 5. All right, and we plug 2/5 I minus 1 into our equation. All right, so we'd have, let's see, 2 minus 2 over 5 squared. All I did is I distributed my 2/5 into here. All right, and then I plugged it in our equation, which is negative x squared plus 5. So this is negative, okay, negative 2 minus 2 over 5 squared plus 5. All right, then this is still going to be times 2/5. And then we go through our summations again. We pick 1. We plug, oh, this is an I here, by the way, sorry. Okay, we plug 1 in for I, figure all this stuff out, see what we get. All right, add it to when we plug 2 in for I, figure it all out. So when we add up the summation again, I did some little pre-work here, and I got 8.08, roughly around there. All right, when I do that summation, I just wanted to show you how we write our summations. We all know how to do summations. All right, you just pick 1, plug it in, figure it out. Okay, add it to when we pick 2 and figure it out. Okay, so I got 0.08. Notice, like I said again, ours is going to be a little bigger. Our area of our curve is going to be a little smaller than what we just found. So in the previous example, we found that our area is going to be bigger than 6.48, but we also know it's going to be smaller than 8.08. Okay, this example here kind of lays a little bit of the foundation of what we're going into next when we're going to break it instead of 5 intervals. We're going to break it into n intervals is what's going to happen. All right, and this will be an n here, and we'll be able to go through some summations and use our summation formulas and simplify that and be able to find the area underneath curved objects using summations. In the next video, I'll show you that, and hope this helps. I'll see you in class tomorrow, and I'll see you in the next video.